Hi everyone. Sorry about that little wait there. I forgot to bring a pen to the camera, so here I am with my pen. I normally like to do it with a pencil, but anyway. I want to go over the solution for this special problem that we did before going on March break. Oh, and by the way, I wish you guys all had a good break. I hope it was relaxing, because the end of the year normally is kind of a bit more difficult, so it'll help that you have had some kind of rest. So what we're going to be doing today is going over this problem, and then I won't be there on Monday to help you guys out, but I want you to be able to kind of do turn this into kind of a special assignment. You'll get the instructions later on, but to do that you have to understand what we're doing here. So I'm assuming that you've already read the question, or at least you've reread the question, since it's been quite a while since we last did it. It asks you for these three values here, and we're going to go ahead and plug those in. I got these just from doing some research. So the force of propulsion from each engine, I got that it's about 200,000 newtons each. The coefficient of drag is 0.031. The approximate heat of combustion of gasoline, I got, what did I get again? 46 megajoules per kilogram. Alright, so those are the values that they're going to help us find the answer. So the question is, how far can something go? And I'm talking about fuel and all that stuff, so it's safe to assume that I'm looking for this formula. Work is equal to the force times the distance. Alright, I'm going to write x in this case. So if I know work and if I know force, I can find the distance at which that much work can go. So now we have to think about how much work can a plane do. And if you think about it, really the only things that's generating any kind of work in an airplane is the motors. So if you figure out how much heat the motors can produce, then we can figure out how much work it does. Alright, so let's do that part first. So I'm just going to start off with a W here. So I wrote in the beginning part of the question that, where is it? Oh no, sorry. I wrote in this part of the question that it weighs 442,000 kilograms approximately. So I'm going to write that down. So we're doing work right now. So the weight of the plane is that many kilograms, and it has about this many liters of fuel. Right? So how could we figure this out? One's in kilograms, the other one's in liters. So to do that, to convert this into kilograms, you have to use density. All right? And the density is 0.74 kilograms per liter. Alright, you can also find that using Wikipedia or whatever. So let's just do that. So in order for me to find how much that amount of gasoline weighs, is 150,000 times 0.74. And that's 111,000 kilograms. Alright? So now if we want to figure out how much the plane weighs empty, you just subtract the two. Like that. And you should get 331,253 kilograms. Alright? So this is the mass of empty plane. Alright. Now we have this value here, right, that there's this much gas. But here in question C here, I asked you what the heat of combustion was, and we know that much gasoline can burn, a kilogram of gasoline can burn 46 million joules. Alright, so let's write that down here. 46 million joules per kilogram. Right? And how many kilograms of gasoline do we have? 111,000. So let's do that. 46 million times 111,000 gives me something along the lines of 5.11 times 10 to the 12 joules. Now that's a lot of energy, all right? But how far is that going to get us? So now we have our formula, right? Our work is equal to force times distance, and we know what our work is. So now all we need to do is figure out the force. Now the force, you might think it's only the force of the engines that are carrying it forward. But that's just the applied force, right? Because as you know, the plane's got to do a whole bunch of other stuff. It's got to fight the wind resistance. It's got to fight gravity. It's got to do a whole bunch of that stuff. So we can't just take this value for our net force. So we're going to have to do some calculations. I'm just going to go to the other side of the page for this part, okay? But we're going to have to remember this value. All right. So the next thing we need to find is force. All right, so let's draw our free body diagram. All right, there's my square plane. There's a certain amount of drag. Oops, not drig, but anyway, drag. That says drag. There's a certain amount of gravity. There's some kind of lift force, right? Because the plane's not crashing downwards, and the engines are carrying it forward. Alright, so there it is. I never said though that the speed is constant, so you can't assume that the net force is zero. What you can assume though is that it's not going up and down, right? Because I told you guys that we're not going to take a look at it taking off or it landing, so we're just going to look at it as if it were just in the air the whole time. So if we draw our x and y forces, alright, we have the force of lift, we have gravity, we have drag, and we have engine. Right? And then also we have the net force. So I said the net force can be zero because it's not going up and down. The lift is making the plane go upwards or maybe downwards, but there's at least no x direction. Same thing with gravity. And drag is only in the x direction, and the engine's only in the x direction. Now, as you know about the engines, the Boeing 747 has 4 engines. All right, so if 4 engines are running at 200,000 newtons each, then the total is 800,000 newtons. Alright, so we can write that here, 800,000 newtons. Alright, for gravity we can figure that out, right, because F is equal to mg, so F is equal to Fg, sorry, is equal to mg. But what is mass in this case? This is the part that you had the most difficulty with. And this is what made it really a bonus problem. So if you looked at it, at the beginning, the plane had how much? 442,253. Now this was mass in kilograms, right? And this is time, right? So it starts off with a mass of 442,000 and it declines over time, right? At a certain point, you run out of gas completely, and that's what we want to find out. So when you run out of gas completely, your jet weighs 331,000. So 331,253 kilograms. Alright? At this point, the mass stops decreasing. Why? Because you just run out of fuel. You're not running out of airplane anymore. So this is the weight of the airplane alone. So you're going throughout this time and you're losing a certain amount of fuel as the time goes on, right? And in fact, you're losing, where is it? I wrote it here somewhere. You're losing 12 liters per kilometer, or, oh yeah, here. It uses about 4 liters every second, right? Because we're talking about time here. Every second, you're dropping 4 liters of gas. And 4 liters times 0. What was the density again? 0.74 kilograms per liter is equal to 2.96 liters per second. All right, so, kilograms per second. Kilograms per second. So you're burning 2.96 kilograms of fuel every second. So in fact, if you want to write a formula for this, you can write that Y is equal to 442,253 kilograms minus 2.96 kilograms per second times x, which is the x-axis here is time. Right, so there's your y equals mx plus b, or your y equals ax plus b. I can't remember which way you learned it. All right, so now we have to find out a mass. Which mass are we going to use to do this calculation of Fg is equal to mg, right? But it goes down over time. It's not stable, so there's not just one mass. So you have to figure out that if you took an average, all right, is running at around halfway between these two, right? So it would be safe to assume that having the mass change over time is the same as having this medium mass over the whole time, right? So let's figure out what that value is. So that's 442,253 kilograms minus 331,253 kilograms divided by 2. This is what's going to be our mass. Alright, so here we go. 442,253 minus 331,253. Divided by 2 plus 1. I'm sorry, that's a plus. That's why it made no sense. So it's 386,000, or M is equal to 386,753 kilograms. All right, and therefore our Fg is equal to 386,753 kilograms times 9.8 meters per second squared. All right. So let's do that. Times 9.8. That's 3 million. Let's write it down here. 3,790,179 newtons. All right. So the force of gravity acts upon this much in the negative direction, right? So we can write down here minus 3,790,179 newtons. All right, and that would mean that your lift has to be just as much because our net force in the y direction is 0. Right? So now we have to use that to find drag. And if you remember in the question, I wrote, consider that air resistance, or drag, is similar to friction using the coefficient of drag instead of the coefficient of friction. So it would be, so the force of drag would be equal to the coefficient of drag times the force of lift, right? Which would be, well, let's just write this down like this. All right? So let's figure out what that force of drag is. Our coefficient of friction, or coefficient of drag rather, we found it was 0.31. We can find that on Wikipedia. And the force of lift is 3,790,179 newtons. And therefore the force of drag is 117,495 newtons. Right? And the drag is going against the plane. So you have to put a minus number. Alright? And now we can figure out what the net force is. 800,000 minus the value that we just found. and that's equal to 682,505. Alright? So there's our force that we need to plug in, newtons. That's the force that we need to plug in. So if we go now to the very end of this problem, work is equal to force times distance. Right? And we find out that our work is 5.1 times 10 to the 12 joules, and that's equal to the force, which is 682,505 newtons, times the distance that it can travel. So let's do the math. And the distance is equal to is that a million? Yeah. I got 7,472,472 meters, which is equal to roughly 7,500 kilometers. Alright? So that would be how far this plane can travel, theoretically. Alright? If there are any questions, please rewatch this video. I'm just going to leave this up for a second so you can see everything. It's a bit messy, but I hope you were able to follow what I was trying to say throughout the video. Okay, thank you.